So the first topic we're going to learn is indefinite integral. In this topic, students will be able to understand the concept of antiderivative, use basic anti-differentiation techniques, understand the concept of indefinite integral, and use basic integration rules. A function f is called an antiderivative of a function f on a given interval if f prime x equals to fx for all x in the interval. For the theorem, if fx is an antiderivative of fx on an interval, then the most general antiderivative of fx is fx plus c, where c is an arbitrary constant. For indefinite integral, the set of all antiderivatives of f with respect to x is denoted by the integral of fx with respect of x equals to fx plus c, where fx is the antiderivative of fx. So why is it called indefinite? Because it involves a constant c that can take on any value. This is the integral sign where we will use to integrate the integrand, and dx is the differential that indicates x is the variable of integration, while we can say this as the integration process, the integral of fx with respect of x. Let's go to the integration formula for several functions and the properties of indefinite integral. Head on the first example. Evaluate integral of 5x to the power of 2 minus 8x plus 5 with respect to x. So here we will use two of the properties of indefinite integral, where we separate each element in this function. So, given the integral of 5x to the power of 2 minus 8x plus 5 with respect to x, so we will use this formula, the antiderivative formula, into each of these separated elements, and we will get 5x to the power of 3 over 3 minus 4x to the power of 2 and plus 5x plus c, where c is an arbitrary constant, where we don't know the true value of this constant. Hence, we will have this final answer, and that's it. For the second example, evaluate the integral of 5 cos theta with respect to theta. So here we will use the first properties, where the constant in front of the function, we will put it outside of the integral. So it is given the integral of 5 cos theta with respect to theta. So when we separate this constant in front of the integral, we will have 5 integral of cos theta, only this one. And we know that if we integrate cos u with respect to u, we will get sin u plus c. So we apply it here, we will get 5 sin theta plus c. Next, evaluate the integral of 4e the power of negative 7x with respect to x. So here we will use the first properties, and for this formula, we know that the integral of e the power of x with respect to x is equals to e the power of x plus c. Then we apply it in the question. We will get negative 4e the power of negative 7x over 7 plus c. Okay, last example is evaluate the integral of negative 5 cos pi x with respect to x. We still use the first properties, where we separate the constant in front of the function outside of the integral, and the integral of cos u with respect to u is equals to sin u plus c. So we apply both of these formula into the question. We will have, first we separate negative 5, put it outside of the integral, and we integrate this cos pi x with respect to x. We will get sin pi x over pi plus c, and we just multiply negative 5, we will get The integral of negative 5 cos pi x with respect to x is equal to negative 5 sin pi x over pi plus c. So I've prepared 4 questions for your quiz. You can try it at home. I already provide the answer for each question, so good luck.
Next, we move to definite integral. Learning outcome. Students will be able to understand the concept of Riemann sum to solve area problem, and also students will understand what is the definite integral. Let's go to the area problem. If the graph given state that you need to find the area under the curve, you cannot simply use the polygon rectangle formula since it has curved side. So we can find the approximate area by dividing it into subinterval. Hence, the subinterval AB is divided into subinterval N. Each subinterval has width delta x equal to b minus a. Construct a rectangle over each subinterval based on the sample point. The sample point can be the left end point, the right end point, and also the midpoint of each subinterval. How do we calculate it? First, we need to calculate the area A of the region R, and then we use the formula height times width equal to fx times by the delta x. Next, the area of the region can be approximated by the sum of rectangles. And lastly, this is the formula. All of this called as Riemann sum. Now for the example, use for subintervals to estimate the area under the curve y equal to x squared plus 1 between line x equal to 0 and x equal to 2. Use the left endpoint, right endpoint, and midpoint of each subintervals. This is the graph when we use the left endpoint. The width of each subinterval is delta x equal to b minus a over n equal to 2 minus 0 over 4 equal to 0.5. So the area can be approximated by using this formula. So this is the last answer. Now let's try. Let's try by using the right end point and also the midpoint end point. You may pause the video if you want. The answer is now. Let's go to the definite integral. We already know how to find the approximate area under the curve. But how do we find the as area under the curve? We will use the definite integral. If f is a continuous function defined on AB and we decided the interval AB into n subintervals of equals with delta, then definite integral of f from a to b is the formula given. If fx larger than 0, then the area under the curve yfx on the AB given by the formula. If fx lower than 0, then the area under the curve yfx on AB is given by the formula. Then this is the formula for definite integral. Example: find 8 dx integral to the limit 2 to 5. So this is how you calculate it. First, you need to do the integral of the 8, and then you need to put the limit the higher limit minus by the lower limit. So you will get the answer. Now, let's try the list of properties. Here are the list of properties for definite integral. Example. If fx dx integral limit -1 to 3 equal to 6, find 4/5 fx dx integral -1 to 3. Thus, by using constant multiple rule, we will get the answer by using this step. Let's try. You may pause the video if you want.
Fundamental Theorem of Calculus. Learning outcomes. At the end of this chapter, students should be able to know the connection between integration and differentiation in Fundamental Theorem of Calculus, understand the concept of antiderivative and computing integrals using antiderivative. Fundamental Theorem of Calculus connects integration and differentiation. To find antiderivative, we need to do integration. If a function is continuous on a to b, then it can be written as below, where capital F is any antiderivative of f that is a function such that capital F prime x equal to fx. For example, evaluate integral from -4 to 3 x to the power of 3 dx using fundamental theorem of calculus. First, we need to find the antiderivative of x to the power of 3. We get it as x to the power of 4/4. Next, we need to substitute the limit into the antiderivative term. We get the answer 175/4. Note that the equation of fundamental theorem of calculus can be written as instead of this equation. Next example, evaluate integral from 0 to 4 square root t dt. First, we need to simplify the term first and find the antiderivative. Substitute the limit into the term and we get the answer 16/3. Try this example by your own. Feel free to pause the video. First, we need to simplify the term first and find the antiderivative. Substitute the limit into the term and we get the answer 49/3. Let's have some exercise. Try to evaluate integral from pi to c sin theta d theta. Find the antiderivative of sin theta and substitute the limit and we get the answer 1 plus cos c. Feel free to try this exercise by your own. First of all, we need to find the antiderivative and substitute the limit and we get the answer. Next, try to evaluate integral 1 to 4 of 1/x to the power of 2 plus x to the power of 1/3 dx. First, we need to simplify the term first and find the antiderivative. Substitute the limit and we get the answer. Thank you.